Hello everyone and welcome to our session of this year's The Things Conference. My name is Markus Ridder and I'm responsible for marketing here at CETECOM. Together with me is our Managing Director, Mr. Markus Ridder, who will guide you through today's presentation. What are we going to talk about today? Today we are going to cover the topic of regulatory approval of devices with LoRaWAN technology. And we have defined the following agenda. We are going to start with a short introduction and then we'll cover the Brexit and the new regulatory requirements for market approval in the United Kingdom. Then we are going to have a deep dive into the approval process of devices with LoRaWAN technology here in Europe, covering the SEN 300/220.2, the 300/328, and then cover the EMC testing, safety testing, and then have an outlook. After that, we have a short look at the market access in the US. This is what we are going to have in store for you today. And for that, I'm going to hand over to Mr. Markus Ridder.
So, hello also from my side to all the participants of this workshop. Welcome to this year's CETECOM workshop at the Things Network Conference. We're proud to be able to present you some details for regulatory approval for LoRaWAN devices. Thanks to Marius Winsler for the great introduction here. And yeah, we would like to start with an introduction regarding regulatory approval in general. So, in general, as per the given directives, any party wishing to put a product onto the European market must prepare a declaration of conformity, a DOC. For that, a conformity assessment is required, and this conformity assessment in terms of radio products is based on the Radio Equipment Directive, which refers to first the EMC Directive 2014/30/EU, which, yeah, self-explaining, refers to the Radio Equipment Directive 2014/53/EU, and it also refers to the Low Voltage Directive 2014/25/EU. This is with respect to safety testing. The basic requirements under Article 3.2 from the Radio Equipment Directive comes with terms that speak of effective and efficient usage of the given radio spectrum. So effectiveness comes in meaning as doing the right things, and efficiency meaning doing things right. The radio equipment needs to support certain features to protect against fraud, so misuse is mentioned here, and it also supports certain functions that ensure access to rescue services. Rescue services, something like e-call from your mobile phone, from your smartphone. It supports certain features that are designed to facilitate their use by people with disabilities, and supports certain functions to ensure that only that software can be loaded which have demonstrated the conformity of their combination. Combination means hardware software with a radio system. So this is also to be named in the Declaration of Conformity. The radio system itself must be designed in certain categories or classes to meet the following requirements. It is compatible with accessoires, in particular with uniform charging devices. So for example, USB-C or something. It works together with other radio equipment via networks. So this is self-explaining, talking about a smartphone, but this might not be self-explaining, talking about an IoT devices like a LoRaWAN. It can be interconnected across unions via interfaces of suitable type, shall have no adverse effect on the network or its operation. So whatever device we're putting on the market must not, let's say, take the bandwidth's 24/7 duration, but it will work, and it will work efficiently on the network. So no misuse of network resources could take place. It has security devices that ensure that personal data and the privacy of the user and the subscriber are protected. So this is the basic introduction based on what is required for European market access, regulatory approval for European market for radio products in terms of Radio Equipment Directive. So coming to the new challenges, and I'm quite of guessing that many of you are waiting for the display and the explanations regarding the United Kingdom Brexit. Let's come to this topic next. So Brexit and the new regulatory requirements for market approval in the United Kingdom. So first, to an introduction also here as well. What do manufacturers need to consider as a second item here for this UK Brexit regulatory approval outlook? The UK CA certification in more detail, the approval process in more detail, then the requirements for the use of the UK CA label, the special case of Northern Ireland, yes, another special case, unfortunately, and the approval process for the United Kingdom here at CETECOM. So in February 2020, the decision was made that the United Kingdom will leave the EU. Just to make up your mind, United Kingdom in this context means we're talking about Wales, we're talking about England, we're talking about Scotland, and we're talking about Northern Ireland. The step has been completed as of January 1st, 21, so not so long ago. England, Scotland, Wales, and Northern Ireland are no longer part of the European Union as of today. This has also an impact of the basic topic we're dealing with, the approval of products with radio technology for various markets, especially for the EU. Here's some new requirements and rules of the given authorities in UK will apply to manufacturers that want to bring their devices into the UK market. The following explanations mainly concentrate on what is necessary to bring devices into England, Wales, and Scotland, as this is part of the introduction. This was part of the introduction already. For Northern Ireland, there are other rules. So what do you have to consider as a manufacturer? Within the scope of the approval of the product launch, you are responsible as a manufacturer that your product complies with the relevant Great Britain, once again, Wales, England, Scotland regulations, as well as for the preparation of documentation such as DOC, Declaration of Conformity. Some items and aspects of this could be delegated to an authorized representative being based in UK. But there are also items that cannot be delegated. Those who have already products being approved and circulating in the UK and the United Kingdom. This is good news first. Whatever has been brought into the market before January 1st, 21 will remain valid. Products can still be sold in the UK. Short excursion here. What means placed on the market? A fully manufactured individual good is placed on the market when a written or verbal agreement or offer of an agreement to transfer the ownership or possession or other property rights in the product have or has been exchanged. This does not necessarily require a physical transfer of the good. So it must not especially mean that your product already is physically in the UK, but everything around this, orders, quotations, and so on, must be signed, must be documented. So sales contracts for your goods that have been manufactured and meet the legal requirements. There are invoices and documents related to the shipment of goods for your distribution. The relevant economic operator, meaning either manufacturers, importers, or distributors, bears the burden of proof that the goods were placed on the market before, double underlined, triple, quadruple, don't know, before January 1st, 21. This also includes the consideration of modified safety and import regulations, which may vary from industry to industry. So just referring to medical devices, there are differences to be taken into account. So what about manufacturers who want to register products in the UK after January 1st, 21? So we have a transition phase here active. This is until December 31st, 21, where you can still use the CE marking, or you're going for the UK CA certification. The CE marking can be used until December 31st, 21 if one of the following applies. You currently affix the CE marking to your goods on the base of a self-declaration, DOC. This means you're using only harmonized standards. A mandatory third-party conformity assessment has been carried out by a notified body, NB, European notified body recognized by the EU, including a notified body in a country with which the EU has a mutual recognition agreement, MRA. So it must not necessarily be a notified body being based in the European Union. It could also be a notified body being based in a country that has an MRA with the EU. The certificate of conformity previously held by a UK approved body, so whoever was notified body for the EU in the UK isn't, at least as of today, no longer notified body for the EU, as the UK and the European Union are missing an MRA at the moment, and transferred to an EU recognized notified body before January 1st. So this should have taken place already. The CE marking according to the European standards are those you can see here. The ones affecting you with the LoRaWAN product are highlighted or are bold printed here. This is the EMC directive, this is the low voltage directive, and the radio equipment directive. And now coming to the UKCA. So despite the transition period granted by the UK authorities until December 31st, the UK authorities make it clear that manufacturers should address and implement the new approval process for the UK as soon as possible. So no big surprise, the authorities want you to switch to UKCA certification as soon as possible. The UKCA certification, therefore, is already also, beside the transition period, active and possible, and from authority point of view, very much wanted. So the UKCA certification in detail. The transition period for CE, or for using the CE mark, ends December 31st, 21. During this period, the use of an EU notified body is also still permitted in order to obtain approval for the UK area. So this is what we already indicated, but written again on that page. If you're already seeking for an UKCA certification now, despite the transition period, the approval process for your product will change. The previously and above valid directives, according to EU law, have been replaced by UK directives, and also the tests have to be adopted accordingly. Given the current inventory, this concerns the following directives and guidelines. You can see on the very left side of this table the EU legislation, and on the very right side of this table the distinctive EU legislation. So here on the left side it's the EMC directive. For the UK legislation, the legal directive is the electromagnetic compatibility regulation from 2016. You can see here the low voltage, and you can see here the electrical equipment regulations from 2016 as well. So for the radio equipment directive, it's the radio equipment regulations from 2017. So this is what matters for LoRaWAN product for the market approval for the UK. This means in general that if you declare compatibility, if you declare conformity of your device according to the legislation, you need to take into account that you declare it to the UK legislation for that. So you need a unique declaration of conformity, having this this regulation's been listed. And beside these regulations, of course, the harmonized standards change. So it's no longer the EU harmonized standards, but it's UK harmonized standards. So for that, you will find so-called BSEN standards for the UK market. What was ETSI standard in the past, also adopting for the UK approval, it is now British EN standards for the UK market that need to take into are valid here. As of today, those ETSI standards, given the example of what is short-range devices up to 40 gigahertz, it's a ETSI EN 300-220-2. Most of you will know this from regulatory approval for the European Union. That one is being adopted into British standard, no longer being called ETSI EN, but being called BSEN 300-220-2. These standards are, as of today, the same standards as, let's say, valid for ETSI. But the door is open that these standards in future will have diverse requirements from those that are currently valid for the European market coming from the ETSI. So it's strongly recommended to check the exact requirements together with a test house, together with us, as products will most probably be changed, and it could affect your product depending on the respective application. So which certification bodies are responsible, respectively necessary? Where mandatory third-party conformity assessments were required for CE mark goods, these are also required for UKCA mark goods. So this means you do not use harmonized standards. The conformity assessment must be carried out by UK recognized conformity assessment bodies, a so-called UKMCAB, United Kingdom Market Conformance Assessment Body, which is the abbreviation UKMCAB, in order to be awarded the UKCA marking. The type of conformity assessment procedures is the same as that required for CE marking. What is very important here, EU notified bodies cannot perform conformity assessment according to UKCA specifications. You need to make use of UKMCABs. Currently, only notified bodies and companies are listed in the UKMCAB list that have a registered office, for example, in the Commonwealth states, or that have a mutual recognition agreement with the UK. So this is, for example, also the USA. Notified bodies currently based in the UK, meaning notified bodies from the EU, will become UK-approved bodies, so-called UKMCABs. Requirements for the UKCA label. So this is no big surprises. This is more or less the same as that is also valid for the CE marking. Just to show, okay, you need to respect some things here. You must not affix any other markings to the product affecting the visibility, legibility, or meaning of the UKCA marking. This is more or less the same you also find for the CE marking. And if you're already going for the European market, this is no big surprise for you. The size of the UKCA label must also not be changed must only be changed proportional. The minimum height of the UKCA marking is 5 millimeters. This is also not new. What I would like to highlight here, the UKCA marking is clearly visible and legible, and it must be permanently affixed to your product from January 1st, 23 onwards. So we have another transition period for the UKCA marking that is extended over the 31st of December 21. So you have one more year to fix this label permanently to your device. I guess your responsible UKMCAB will guide you with that. Special case of Northern Ireland. What is special here? The UK CA marking will not be recognized in Northern Ireland. So why is this? The Northern Ireland Protocol entered into force January 1st, 21. And as long as this is in force, Northern Ireland will comply with the relevant EU rules for placing industrial goods on the market. Products that currently require CE marking for sale in the EU will continue to require CE marking and will need to comply with the EU regulations. Means, if you have a CE marking on your device, the Northern Ireland market is still open for you. So this is the same as we had for the UK CA, but this is only valid for Northern Ireland. What is new is the UK NI mark. This comes into view if you use a UK body, UK MCAB, to carry out mandatory third-party conformity assessment. With that, you must also affix an UK NI marking. The UK NI marking is never affixed alone on devices being distributed into the Northern Ireland market, but always in conjunction. So you have two markings on your device with an EU conformity marking such as the CE. Goods that bear both CE and UK NI markings may not be marketed in the EU. So this is the same as we had for the UK CA mark. No other markings may disturb, if to say so, the original marking. So you do not need to make any changes if both, double underlined, of the following applies. You're a manufacturer established in Northern Ireland or the manufacturer's authorized representative, and you currently mark your goods on the basis of a supplier's declaration of conformity, sometimes referred to as self-declaration, DOC, declaration of conformity. So CE marking, you can affix the CE marking to your goods when any of the following applies. You're currently affixing CE marking on the basis of a self-declaration. So quite clear, self-declaration, Northern Ireland is special. A required third-party conformity assessment has been carried out or performed by a notified body recognized by the EU. So you're using non-harmonized standards on ETSI base for the European Union. So continue to sell your product, distribute your product into the Northern Ireland market. And under these circumstances, goods bearing the CE marking may be placed on the market in Northern Ireland and the EU. How can you use the CE marking, or when you must use the UK NI marking alongside the CE? So I think we already made this clear. This is if you plan to engage a UK body to carry out conformity assessments. You cannot use the UK NI marking if any of the following applies. You're placing goods on the market in the EU, UK NI is not valid. You plan to commission an EU body to carry out the mandatory third-party conformity assessment. UK NI is only to be placed on the product you have in an UK MCAB. So for the marking itself, the same applies as for the CE label as well as for the UK CA label. So this is just informative. So summary. Placing goods on the market in Great Britain, manufactured goods being placed on the Great Britain market until end of 21 can have UKCA or CE marking. Placing goods on the market in Great Britain, manufactured goods placed on the Great Britain market from January 1st, 22 onwards only are valid having the UKCA marking. Okay, so a lot of stuff you have to take into account. You have to bear in mind talking about Brexit and United Kingdom. Now coming back to the European market again and giving you an overview about regulatory approval for devices of LoRaWAN technology in Europe, touching some standards, testing, coming over EMC testing, safety testing, and also giving an outlook of the regulatory approval for LoRaWAN technology, and also having a short dive into market access in USA. So Europe now. We already talked about in the field of the introduction about the Radio Equipment Directive. Radio Equipment Directive inhibits the given harmonized ETSI standards, the EMC Directive and the Low Voltage Directive. The standards here are mainly ETSI standards that apply mainly is good. So there are only ETSI standards that apply. And we also have an ERC recommendation, European Radio Communications Committee, that defines technical parameters and fields of applications for short-range devices, which LoRaWAN devices apply to. So giving you an overview about the regulatory approval schemes, regimes, national approval regimes of the world. So one can see that everything that is blue colored here sticks to European rules, to European standards. Everything that is orange goes according to national requirements. Everything that is gray goes to FCC. Everything that is, let's say, all of this either applies to European, national, or FCC requirements. Just to show you which countries you may distribute your device in according to the testing and approval regime you're choosing. Coming back to Europe. So we've listed here 3 standards mainly that come along with the frequencies used for your LoRaWAN device. So if you use 433 megahertz, it's the ETSI 300-220. The same applies if you're using 868 megahertz, it's also the ETSI 300-220. If you already have devices using the 2.4 gigahertz range, it's the ETSI EN 300-328. We put here the latest sheets, the latest versions of the standards. So for 220, it's version 3.2.1 from 2018. And for the 300-328, it's version 2.2.2 from July 2019. Here we had to add information that the former version, the 2.1.1, will leave its transition period by August this year. So from August this year, 21 meaning, you have to apply the 300-328 in version 2.2.2. But you can contact us, we can help you here if your device has been tested to a former version of that. Yeah. Where can I find harmonized standards? Where can I see which route I have to take? Do I need a notified body or not? We put inside here some information, the ETSI portal, where you can find the harmonized standards. This is definitely the latest information one can get, and this is where you can see which version of the standard can be applied to your product, and we definitely recommend to always take the latest version of the standard. So radio products in the European Union need to comply to the latest versions. Usually there's a transition phase as the one being mentioned for 300-328. But when the transition phase ends, your device needs to comply to the latest standards. And if you have in a declaration of conformity pointing out to older versions of the standards, this declaration of conformity may not be valid anymore. So also in this case, do not hesitate to contact us in case of any questions. Short introduction to 300-222. Oh, sorry, we have a typo here. This is 300-220-2. You can see in the harmonized standard many of those test cases. Operating frequency, unwanted emission in the spurious domain, TX effective power, and so on and so on. So for typical LoRa equipment, LoRaWAN equipment especially, these test cases, marked in red here, do not apply. TX behavior under low voltage conditions, FHSS, indicates a frequency hopper. Even if we know that LoRa and LoRaWAN devices hop over at least 3 channels, if I'm informed correctly here, this is not been named a frequency hopper from ETSI point of view. They name a device a frequency hopper if there are 40 consequent hops of a device into new channels. So this, for example, applies to Bluetooth devices. So in my opinion, LoRa is not affected here. So this comes down to a number of 9 test cases that are required for a LoRaWAN device. we would like to show the unwanted emissions in the spurious domain as an extract here. We could also have chosen one of the other test cases here, but okay, let's take this one today. You can see that these are screenshots of a spectrum analyzer. The very left one shows a transmit of a device. You can see the bandwidth of the transfer, and you can see on the lower on the upper left and on the upper right side the given spectrum limits. Looking into the harmonics of such a device, one can see that we see harmonics of this device in the so-called spurious domain. We see different. This is a conducted measurement, by the way. This is not radiated. Anyway, we can see. Hope you see my mouse pointer now. You can see the distinctive frequencies here. So the base frequency is 868 something, and we can see here the markers on the middle screen showing different peaks and indicating, okay, it could happen that that one of these peaks is above the limit. The limit here is given with minus 30 dBm in the spurious domain. And we look into more detail regarding this amplitude here having the right resolution. One can see that this one here is very close to the limit, looking more detailed. So whatever is in the 10 dBm range here would be investigated in more detail. This is still okay, even if it's 0.24 dBm below the limit, but below the limit is, I'm sorry, it's below the limit, but it looks quite critical here. This is what is checked in the unwanted emissions in the spurious domain. As I said, this is a conducted measurement. Coming to the ETSI N300-328 market access for the LoRa products in the 2.4 gigahertz range. I know that some of you will not refer to a LoRa product using devices in the 2.4 gigahertz range. Others do. So let's stick to the 2.4 gigahertz range. It's the ETSI 300-328. This is the same standard that applies to Wi-Fi products in the 2.4 gigahertz range. This applies to Zigbee, this applies to Bluetooth, and okay, for LoRa products in the 2.4 gigahertz range, it also applies. Here also we have 13 test cases that can be brought down to 11, but this depends on your device in the end. So geolocation capability usually does not apply to LoRa equipment. For the medium utilization and for the adaptability, it depends on the output power of your product. So we can take out number 4, we can take out number 5, we can take out number 13, and number 6 and 7 depend on your output power of your device. 10 dBm means this output power is being measured conducted. So the demo, we would like to show number 8, occupied channel bandwidth. So here you can see the occupied channel bandwidth of a LoRa device running in the so-called LoRa 1600 mode. You can see that the occupied channel bandwidth here is about 1.7 megahertz. The limit for non-adaptive systems is here 20. So this definitely complies, and you can also imagine that this is different, for example, for Wi-Fi. So LoRa does not have that bandwidth even in the 2.4 gigahertz range, even if we definitely have a difference here compared to the 868 transmissions. So the same picture for the FSK, frequency shift keying transfer. One can see that the occupied channels bandwidth here is about 2 megahertz. So still far away from the 20 given by the limit in the standard. So this is just one test we want to show you here. It could also have been any other, just to make sure, okay, 328 applies also to LoRa devices and to LoRa devices in 2.4 gigahertz range. What do you also have to take in mind? EMC testing. So sometimes this is pretty much forgotten as we're talking about a radio product. Okay, EMC testing, this does only apply to devices not having a radio interface. Okay, but this is not correct. We took the example here from the ETSI N30149-3. -3 applies to LoRa devices in the 868 domain. One can see that all clauses here, all classes, test cases apply, and these are the same test cases as we have for a device not having a radio interface. So emissions, DC power input, output ports, flicker, wired network ports, and which test cases in the end you have to apply to your device. This pretty much depends on your specification. Is it a pure radio module? Do you have any interfaces like a temperature sensor? Do you have a mains power supply for your device, or is it battery powered? So it cannot be estimated without having a specification. We want to go a bit more into detail. For example, on the very left, one can see an ESD, electrostatic discharge table. ESD might be required for your device. So this one is conducted testing here, conducted immunity. This applies to any interface coming with a wired interface being longer than 3 meters. So 2 meters, 99 is safe. 3 meters, 3 meter 1 requires testing according to that one. We're talking here about radiated emission. Radiated emission is usually been tested. So of course, you have some wanted emission. This is a transfer of your LoRa signal. But beside that, your device has to comply to the EMC requirements given in the respective regulations. This is the radiated immunity testing. If your device is being used in consumer electronics or in consumer area, 3 volt per meters interference strength has to be tested. If it comes to industrial area, 10 volt per meter immunity are tested. If you're having a power supply or network communication with your device being longer than 3 meters, also this indirect lighting is tested. And yeah, so this should just give you an overview about which EMC testing is necessary and that EMC testing might not be neglected. Another item is safety testing. Since December last year, the old DIN EN 6951 is no longer valid. This one has been replaced by the 62368. What has been tested in this standard? The risk in form of danger should be reduced to a minimum for any human or animal. So this is more or less comparable to what we read in the very beginnings of the Radio Equipment Directive. So household animals, domestic animals, and of course humans might not be harmed by the operating of your device. This one has been tested against electrical shock, danger of energy, hazard because of fire, danger because of heat, mechanical danger, yes, no sharp edges allowed, danger through radiation, or also chemical hazard. The standard, the low voltage directive, applies to any radio product, and we do not have a lower voltage limit. Talking about devices not having a radio interface, we have a lower voltage limit of 50 volts. So this is, for example, one reason why power over Ethernet runs with 48 volts. This is below the 50 volts and no safety testing is required. For radio devices, this lower voltage limit does not apply. So whenever a device comes with a radio interface, even being operated with 1.5 volts, safety testing is required for given a declaration of conformity. And given a declaration of conformity according to Radio Equipment Directive, as the low voltage directive is being referenced in the Radio Equipment Directive. The principle of electrical safety. So we have requirements for normal operation, we have requirements for fault operation, and this means predictable fault or unpredictable fault. We need to have safeguards being effective, and it is not allowed that danger to life and health of person or property during the entire lifetime of the device occurs. Giving you an example, you have an extension of a power cord that you're using outdoors, and this works fine for about 1 year, and after 1 year the plastics is broken due to ultraviolet, let's say, altering of your device. And usually a lifetime of such power cord extension would be, let's say, 3 years, 4 years outdoor, depending on the standards being tested, and it does not fulfill its isolation any longer than 1 year. So this must not occur with your device being run outdoors. So the directive 2014-35 has also to be covered, and it is pretty much recommended to apply the harmonized standards as they relate to the directive. So here also we have put inside a link to the harmonized standards for the 2014-35 EU. It must not necessarily be in the 62368.1 as we're talking about today, It can also be another standard, but most of product standards refer to the 62368. The 62368-1 is not in general a merging of the previous standards, which is the 60065 and the 6950, but the approach is completely different. That one is a hazard-based safety engineering standard, a so-called HBSE. This covers the scopes of the previous standards, 60065 and 6951, and it will also replace 40% of all existing CB schemes. Remark, this is not a risk-based standard. It's a hazard-based safety engineering standard. Okay, what does this mean? The HBSE model. First, we have to identify, for example, the energy sources. Is the source hazardous? Identify means by the energy could be transferred to a body part. Then design a safeguard which will prevent energy transfer to a body part. Measure safeguard effectiveness. And if the safeguard is effective, you're done. If not, safeguard has to be redesigned. So we're first talking about the energy sources and their classes, class 1 to 3. We would then identify the power source and the power source energy according to 1 to 3. Then identify chemical hazard and respective safeguards. We then identify mechanical energy sources, identify the thermal energy sources, and in the end, identify radiated energy sources. So this mainly refers to ionizing radiation. So talking about EMF, electromagnetic fields, this usually is non-ionizing radiation. Ionizing radiation comes from nuclear sources. These are meant alpha, beta, gamma radiation, for example. Hazard-based safety engineering. What is hazardous? A hazard, an energy source that exceeds body susceptibility limits. So hazard, touching liquid that is 50 degrees warm, not talking about hot, usually may not be referred to as being hazardous. But if this liquid is 100 degrees hot, this definitely exceeds the body susceptibility limits, so boiling water. Safety, a situation where at least one safeguard is interposed between the body and a hazardous energy source, meaning if you're touching 100 degrees hot water, make sure you have gloves on your fingers, on your hand. Hazard energy sources can be electrical, like shock or fire, chemical, thermal, in terms of heat, mechanical, and radiation. The energy transfer is based on the amount of energy and the effectiveness of the transfer mechanism. The amount of energy, okay, how much energy is present? Is it harmful? And the effectiveness, can the body be harmed by just touching, or do I need to drink something? So just effectiveness of transfer. Injury occurs when energy of sufficient magnitude, amplitude, and duration, very important, is imparted to a body part. So here's a model behind that. Giving you some impression about what could happen: energy shock, pain, fibrillation, cardiac arrest, respiratory arrest, skin burn, internal organ burn, according to clause 5, electrical power, energy, chemical injury like skin damage, lung, other organ damage, poisoning, kinetic energy, and so on. I do not want to go in too much detail here, just showing, okay, this has to be taken into account. Please bear in mind, safety testing is necessary, and we have those 6 types here. So this is a summary for 623.681. Classify persons who have access to the equipment. So this is also new in this standard. Ordinary persons, instructed persons, and skilled persons. Ordinary person, this might be my grandma. An instructed person, this may be an employee in the company having, let's say, at least a rough knowledge of what is currently happening. And a skilled person usually is a supervisor, that is a trainer, that is able to coach people, to give guidance in terms of handling hazardous devices. The energy sources need to be classified according to the 3 classes given here. So not touchable, not recognizable, whether it's already been painful but no injury, and class 3 would be an injury. We need to classify the type of safeguard for each hazard, whether it's an equipment safeguard, an installation safeguard, personal or behavioral. So possibly it could be something like a remark saying, okay, please turn off energy before opening the housing. And it also needs that we have to classify the operating conditions. So normal use case that can be expected, single fault, single safeguard, and abnormal operating conditions, so also taking into account abuse of your device. Outlook on regulatory approval for LoRaWAN technology. So what will be new in future? We will have a new band in the frequency range of 870 megahertz to 875 megahertz, where a duty cycle of 2.5% is possible. So you all know that currently the duty cycle in the 868 band, harmonized band all over Europe, is much less. And you may also be able to transmit with 500 milliwatts of equivalent isotropic radiated power. And this is based on the EU decision 2018-1538. The current status of this draft at CEN 303.204 is that it's in the voting status, and the voting started in December 22, 2020. The official journal, which is necessary getting this into a harmonized standard, is now planned for June 21. Originally, it was planned for May. This may be a COVID-19 impact. So what does this mean in detail? We have additional frequency bands. These frequency bands are not harmonized all over Europe. You can see here, let me show with the mouse pointer, that you possibly have more power you can use. You have a higher isotropic, equivalent isotropic radiated power possibility. It's not 25 milliwatts any longer in this band, but you need to comply to the other parameters given in this table. These bands, for example, are not possible in Germany. So 917 megahertz, 916 megahertz, this is railway communication in Germany, just to have this as an exemption. Other countries are possible here. Yeah. Showing this in more detail, the countries where this is possible, this is implemented, for example, in Russia, in some areas in Eastern Europe. We have it in the UK where it's possible. We have it in Norway. Germany, not available. So just to make sure, if you're using this and if you're using this exclusion, this new bands, this new equivalent isotopic radiated power, make sure you stick to these countries. Coming to the USA, finally. So to sell a product into the USA, the Federal Communications Commission is the organization that gives the rules. If you take this, people are talking about a law book already. This is quite a thick one for the FCC rules and regulations. These are quite a read, one says. The FCC requirements cover interference only, so they do not take care about interference and immunity, and they do not necessarily need product safety. So no 62368 for even not for the safety standards that may be available in the US, but these are not required. These are not mandatory. FCC for private sector telecom industry means the FCC establishes technical regulations for transmitters and other equipment to minimize their potential for causing interference to other radio services. So this is intentional radiation. FCC administers an authorization program to ensure that equipment reaching the market complies with the technical requirements. Interference control is in public interest. So since November 2nd, 2017, there are two possibilities to get into the European market with your product. First, supplier's declaration of conformity, SDoC, or the certification route. Which route you can take for your device depends on what type of device you have. Types of equipment for the US also partly applies to the ISAT, which is Canada. These are unintentional radiators, which is IT equipment and receivers that come along FCC Part 15 subpart B. This only means EMC testing. Unintentional radiators for unlicensed use. These are transmitters. Unlicensed use means you're having like ISM bands. We have in Europe 868 megahertz. In the US, it's 915, for example, for the LoRa device. These are transmitters coming according to FCC Part 15, subpart C, D, E, F, G, and H. And intentional radiators for licensed use. These are transmitters, for example, work in mobile communication. LTE, UMTS, 5G, whatever. These are intentional radiators for licensed use. So how to approach the US market? First, understand the type of your device. Having an unintentional radiators comes according Part 15B. Industrial, scientific, medical, it's Part 18. You have a transmitter in unlicensed band, it's Part 15C mainly. Transmitter licensed, Part 22, 24, 25, 27, 90, 101. It could in general also be multiple parts applied if you have several radio interfaces being built into your device. Given the example, you have a LoRa interface and you have in Bluetooth. So it's not just one testing and one part of the FCC Part 15, but it's more than one. The authorization route is given in the rule part. So if there are multiple of them would apply. If we're talking about short-range devices, you have to use the certification approach. The SDoC, so self-declaration, is not possible here. The manufacturer has the device certified for the use. You need to perform the required tests. You need to ensure that your test house of choice performs the required test, and you have to ensure that your device meets all FCC requirements. The technical data needs to be compiled. It's a so-called technical construction file, TCF, which contains schematics, bill of materials, photos, block diagrams, and the user manual. All this data needs to be submitted to a so-called TCB, telecommunication certification body, that checks and uploads your data. So you send in what you want to bring to the US market. You accompany your device with the given documentation, and then you receive a grant of authorization from the FCC. The TCB uploads your data to the FCC, and comes along with his personal opinion that your device complies with the requirements. In the end, your product needs to have a label that must show a unique FCC identification number. That one consists of a number that is a grantee code that more or less describes your company, respectively your local representative, and then a code that can be freely used for your product. I think it's 7 to 8 digits at the moment. Showing this, your device can be brought into the market. By the way, this FCC ID must be readable also on the outside of the packaging, so it is not sufficient to have it on your temperature sensor inside a package, inside a box. So we hope that this gives a good overview of what is necessary for the European market approval, for the UK, United Kingdom market approval, also having the additional route into Northern Ireland. That gives a good overview about the testing, about what you have to comply with, and showing some examples of the European standards. And it also touches bringing your device into the USA market. If there are open questions on your side, you will find our contact data, and you are heartily invited to give us your requests regarding our presentation, regarding any questions that arose on your side. And we would be very pleased to help you through the approval process for the European Union, for the United Kingdom, for the USA, and for about in total 220 countries we're offering in terms of international type approval here at CETECOM, based in Germany. So thank you very much for your patience. Thank you very much for your attendance. Have a nice day, stay healthy, and greets from those two guys at CETECOM doing this webinar for you. Have a nice day. Thanks and goodbye.